Datrium, how you pronounce it? Datrium. We had Mark Sullivan, who's in charge of the sales for the company, and our system engineer, John, who will be talking about the SAN, HCI, SDI, which is software-defined infrastructure. HCI stands for what?
HyperConverged
Infrastructure. Okay. And SAN, everybody knows about it. But basically, everything is starting to go towards the software-defined management of or anything, whether it's network or storage. So, and even Cisco, who's been very hardcore in hardware, is going that route also. So it's really something that one needs to pay attention to. So Datrium has developed a new infrastructure called Open Converged Infrastructure that has some characteristic of the HCI, SAN and SDI technology. Their approach was to bring in the best aspects, features, and benefits of these technologies without the rigidity, cost, and complexity that is often involved. We will also see how this new architecture lends itself to efficient backup and disaster recovery, as well as hybrid public cloud integration. So, John, just can introduce yourself more as a background, but
all set?
Yeah.
All right. Well, again, I'm John Shedlosky. Thanks for having me. Let me just kind of take a poll. As far as your experience here, what is the ideal length of a discussion at this meeting? Is it half an hour? Is it an hour?
45 minutes.
45 minutes.
We have to be out of here, what is it, 9 o'clock?
Oh,
8:30?
No,
okay.
Yeah, but we gotta.
I just want to make sure. Okay. About an hour, plus or minus,
If
maybe a
anyone
little
falls asleep, we'll
minus.
stop talking.
Yeah,
I
that's
love
the
it.
problem.
up to 8:45.
Easy, no problem. So again, I tried to make this, Mark and I do sales presentations all the time. I tried to make this a little bit less salesy. Try to do a little bit more what our perspectives are, maybe the perspectives of the company, knowing that there were some students here. Again, I think it's awesome. What class were you guys taking that you guys learned about RAID?
Intro to computer science.
I love it. I love it. Were you actually coding any RAID algorithms or just the concept
Just the
of it?
idea, the concept.
Yeah, all right. I mean, why are Mark and I here? Again, I go back to 1999 as far as dealing with enterprise storage or enterprise infrastructure, enterprise storage. Some folks less, some folks more, probably in the room. I'm not going to put Mark on the spot. Mark, when we were kind of putting this together, we only remembered the successful companies. I remember two of mine that
for a while.
weren't. I know one of Mark's that wasn't successful either.
Well, it
But
was on paper.
right, yeah, until it wasn't. But I just thought about that. I'm like, it's easy to forget about the misses. But it's fun. I love working with new technologies. I love evangelizing new technologies. That's the really fun stuff for me. And again, I would argue, we can talk afterwards. Any of the students in the room, I think it's a no-brainer way to go. Go where other people are not going. Go to a company with 50 people at it, 10 people at it. That's such a great way to just drink from the fire hose, learn new and technologies that may fail, or it may change the world, or somewhere in between. But you can just do that a couple times early in your career and just go for it, especially around Boston here. There's so much great stuff going on. Something really cool about enterprise storage is that relies on both evolving hardware technologies from my perspective, as well as fairly rigid data layouts. When you kind of pair those together, and again, if you look at the history, and a bunch of the folks in the room here probably have seen it over and over again, probably more than me, that every 5 or 10 years, just the entire industry blows up because something has changed. So, something in the hardware, maybe Intel releases multi-core CPUs, maybe SSDs come out, maybe something in the disk technologies change. And if you look at all the software functionality in enterprise storage, again, we can talk about it, but things like snapshots, deduplication, compression, thin provisioning, all these things, until they were around, obviously they didn't exist. But to do them really well, you have to have the fundamental data layout be designed to allow them to do them in an efficient way. If you didn't do that, your data layout is not going to work. So it leaves a great spot for some new company, some new technology that doesn't have millions and hundreds of $1 million of investment behind it, tens and hundreds and thousands of customers. As a new company can come along and build something just wildly more efficient. That's what's really cool about enterprise storage in my mind. And again, look at the public cloud. Folks like Amazon, things like Microsoft. Who knows what the industry is going to look like in 5-10 years? It's getting blown up again. And again, it's nearly impossible to rewrite an enterprise data layout once you've done it because you have so much vested interest in that. Meaning that, again, in my, just shy of 20 years, looking at the various places in enterprise storage, it's blown up 3 or 4 times already and gone through complete rewrites. And that's what's kind of happening now. So, I don't know. When it comes to enterprise storage, enterprise infrastructure, what makes the most sense? And maybe kind of it might be chaos, but in this room, I mean, what makes the most sense? I mean, I feel like there's a lot of pretty savvy folks in the room. I mean, are folks going to the public cloud? I mean, obviously we're going virtual. But I mean, what have folks been, what do you guys see as far as recently pushing the efficiency curve? Is anything really jumping out at you?
Azure and AWS.
Azure, yeah. Sure, public cloud. Absolutely. You guys were talking about Nutanix, HyperConverged. Absolutely. We were just talking about physical to virtual. Containers. Absolutely. That has absolutely a lot of folks really thinking about, virtual machines are a whole bunch more efficient than physical. But when you can containerize processes, you can spin them up and run that process in a second rather than have to boot up a whole new virtual machine. So again, kind of maybe by a show of hands, with Microsoft, Google, Amazon, being the next big wave, is on-premise infrastructure obsolete?
No.
Okay. Anyone disagree with that? Okay.
No, I've learned going to the cloud to be very wary of it. If it fits a very specific need, fine. If it doesn't, don't follow the herd.
No, I'd agree. And again, I think when you're looking at a use case, is it cheaper to rent or own? Again, I mean, it's a silly analogy. But if we have a family reunion, 50 people coming, obviously we're not going to buy 50 cars. We're going to rent them. Use the public cloud. If I've got to commute every day to work, I'm not going to rent. That doesn't make sense. I'm going to own my car. We're going to run it.
Another perspective is I have a business with lots of customers. What works is what they want.
Oh, sure.
So regardless of what anybody's saying, each one has their reasons for wanting what they want, and you bring it to them, and if you don't want to, then somebody else will.
Yeah. I mean, just a couple of anecdotes. Again, Mark and I I bet a lot of, do you have a comment?
Sure, and until someone can make fail-safe security and make data
Security?
breaches obsolete, people will always be, a little bit leery about putting the crown jewels, up where someone else can get at them.
Yeah.
So that's a big.
But isn't the main point, is the hybrid idea? I mean, which is precisely addressing this point. We're saying, look, a medium to large size enterprise has got a portfolio of data types. It's got an information life cycle. And some of the stuff is less, so you divide up what you can sort of safely put on the public cloud and what has to stay. I mean, that seems obvious.
Yeah, I mean,
you get a mix. And it's like your stock portfolio, and you've got some over here, and then you got some bonds.
Yeah. So again, I mean, just an anecdote. Mark and I were just talking to I won't name him, You know, one of the biggest universities, well-known, their CIO was saying everything, to contrast, he was going to the public cloud. He had his job for 2 years. And now they're saying, yeah, public cloud makes sense in some areas, but not at all. I mean, another customer I was talking to, they went into one of the public clouds, they get 300 gigs of high-performance SQL data. It's a database. A lot of transactions, a lot of this and that going on. Their monthly cost was $15,000 a month for 300 gigs. So again, think about that. You know, your iPhone might have 300 gigs in it. So they're paying $15,000 a month because of all that transaction going on. It may not make sense to do that. But again, if you're thinking about the public cloud maybe as a DR site, maybe I'll replicate all my data up there. And it's just going to sit there very, very cost efficiently until I need to turn it on, until there's a hurricane, until there's an outage or something like that. Okay. Well, some of these different use cases might make a lot more sense.
What's interesting with the cloud debate, and I've called on the biggest enterprise accounts from Florida and Toronto for the last 10, 15 years, and the big push in some of the biggest hedge funds and financial institutions over the last 4 or 5 years was to have some outsider leadership team come in and say, you're going to the cloud, period, end of sentence. And I happen to have the biggest hedge fund in the United States of America as a client for 4 straight years. And they had 18 people in the data management, data support, data infrastructure, disaster recovery team. And 3 years ago, we were doing probably about $500,000 a month shipping them flash storage. And they got a new outsider came in and were mandated to go with the cloud. And be an infrastructure supplier, we made it clear to them the associated risks. Certain data resides on the cloud in a good, safe fashion, but client data, especially in the financial industry, the critical nature of that, even an outage of a half hour can quantify it to millions, tens of millions of dollars in lost revenue within an hour. In lost clients forever.
I thought there were regulations for financial institutions in this respect. Am I thinking about some other constraint somewhere else in that?
There's
things they can't do.
You're exactly right. There's regulatory and compliance and edicts and directives and mandates and SEC regulations. The point we're bringing up was a tier 2 application, not a tier 1, not a tier 0, but a tier 2 application, which didn't need instantaneous access to the clients. Happened to go down for hours when last year that giant Amazon outage hit the whole East Coast. Of anyone that heard it, it hit everybody. My point being, they're now retrenching their strategy. In the 4 years I've seen, the biggest company in the United States, wasn't my client, went to the cloud. They've taken everything back on-prem to some of the points you folks made. Security, accessibility, retrievability, and they don't want anyone getting hold of their crown jewels, which is their intellectual property.
One of the challenges I have recently is, as I've said, most of my customers want to be on-prem. And now, for the first time, I'm in circumstances where I'm looking for applications for them. I can't find on-premise applications. Everything I find is in a particular category is web-based, stores in the cloud. And so the
Software as a
migration
service.
of applications moving to the cloud is starting to impact my ability to find on-premise
The
applications.
challenge you have with an on-prem, it doesn't necessarily assure security and access and safety.
Agreed.
Unless you put together a multi-pronged disaster recovery plan,
Yeah.
so that if you lose a site, and we had some of the biggest complex customers in the United States when I was at 3PAR, we'd be replicating to 2 or 3 or 4 different sites simultaneously, so that if this heartbeat went down, you still had access here, you had access there. You had a multi-tiered protection schema for your on-prem. Never mind, this was pre-cloud 8 years ago.
Yep.
So the raging debate will continue to rage because there is no exact answer. And what will happen over time is the market will decide.
How do you make the argument that having your own storage and server is more secure than having it stored over the cloud, it's Amazon, because for a layman person, you think Amazon has much more resource to protect that. Whereas
Your point is, the interesting thing is we have had some of the most complex, sophisticated clients I've covered in the last 6 years, that the reason they went to the cloud was that they were given guaranteed service levels, guaranteed levels of protection by the different cloud providers, whether it's Microsoft or in this case, Amazon was the client that I lost to Amazon. Because they were guaranteed there were 6,000 people looking at their data and their infrastructure 24 hours a day forever, versus 5 people in this small little regional bank. So, again, I don't have an answer for it, nobody does it. If they tell you they have an answer, they're misleading you. The market will dictate how things end up, is my belief. I've been in this business 30 years.
All right, again, all good discussion points.
Sorry about that.
Yeah, but the market
so-
doesn't always dictate correctly either.
Absolutely right.
So again, this is sort of free for all. You get a hat if you shout out an answer.
Or even if you're quiet.
If you've got some on-premise storage, what are some ideal quality? I mean, let's talk crazy. I mean, you can have everything. What do you want?
Fault tolerant, redundant.
Okay, you want reliability. Okay, I
Oh,
mean,
yeah.
what else do we want?
And protection, against hacking.
Security. All right, I love it.
Maybe encryption.
Anybody else?
Easy to expand.
Easy to use. Oh, scalability. Yeah.
Scalability.
Easy to use.
Easy to use is very important.
Yeah, yeah. Does anyone like performance?
Oh, yeah,
Okay, a little speed. Does anyone like inexpensive?
that'd be nice.
Okay.
But not to a point where you sacrifice.
You know.
No, we're dreaming.
Degradation, reliability,
Well,
and
this
performance.
is the old triad.
Yep.
Speed, reliability, or quality, too.
The trade-offs, right.
So here's the ones I came up with. Inexpensive, fast, predictable, scalable, easy to manage, elastic, integrate backup recovery, public cloud integration, secure. I think we're kind of all in agreement. And I also agree with with what's out there, it's tough to get all of these. You might have to select 4, or you might have to select some number of them based on your environment and budget and everything else. And really based on a SAN. And we'll talk about what these are. Again, you can raise your hand and say, I have no idea what a SAN is, or I don't know what HyperConverged is. And I'm gonna about to get into these. But if you think about what a SAN can do, what HyperConverged can do, what software-defined can do, you're generally getting, again, 4 or 5 of that list of 7 or 8. And again, SANs are very reliable, very predictable, very scalable, also very expensive. Maybe not the best performers. HyperConverged, again, very granular the way they scale. Very easy to use. A lot of data management in
What's
there.
the negative part of hyperconverged?
We'll get to that. Maybe cost. It could be cost. It could be complexity of performance isolation. There could be a bunch of things in there. We'll definitely dive into this.
Performance with hyperconverged, they have to go hand in hand. You can't decouple them.
Yeah, we'll dive into that. Software defined. Again, it can do everything on paper. It's very inexpensive. You get to choose your own hardware. Commodity is good, but it can also introduce a whole bunch of issues around compatibility, reliability, things like that. So if we kind of go through those big buckets, what a traditional SAN is, again, sorry for folks that don't know, again, there's no harm in raising your hand, but does a SAN need to be defined?
Yes.
Yes, okay, perfect. So a SAN is a storage area network, and that's sort of a catch-all phrase for this architecture. You have some servers up here. Again, in ESX cluster, I'm just sort of assuming folks are running VMware, which is a virtualization technique. So I can run n number of servers or desktops on one physical machine. It's really cool. Have you guys talked about virtualization yet?
Yes.
All right, love it, love it. So you have some number of physical servers, hypervisors, accessing a SAN down below. SAN, it's essentially a highly redundant storage array that's running RAID. So you have your media down here, in a RAID 10, in a RAID 5, in a RAID 6, some RAID level down below, and it's being served up by usually dual controllers. There is some variation to this architecture, but usually you've got redundant controllers that are doing that work down below, and they're doing a lot of stuff. They're doing those RAID calculations. They're serving up reads and writes. They're doing file system maintenance. They might be doing encryption. They might be doing deduplication and compression. Compression is essentially compacting small chunks of data. Deduplication is compacting similarities between, or identical chunks of data between larger areas of the file system. So they might be squeezing things down there. They might be replicating somewhere else. So these things are doing a lot of stuff. So in my opinion, what's really good about this? Again, what do people like about SANS?
Well, we're also running on a dedicated backbone, so if you
Yep.
need to move 100 gig of data or 100 gig application from one storage array to another, you're not bogging down the rest of the network and
Yep.
tying up your end users.
Yep. Oh, yeah.
I associate this with a Cisco switch. I mean, that's where I see it looking over somebody's shoulder, and everything's
Yep.
connected to this thing
Yep.
by fiber. It says
Yep.
it there. That's an important part of what a SAN
Fiber,
is.
Yeah.
And they can just, the SAN administrator sitting with his Cisco screen can just
Carve it up.
carve everything
Yeah.
up and aim different, aim that, oh, I want to aim that guy at a different server.
Right.
I want to aim that server at a different guy. And it's, pretty cool.
Yep.
I mean,
Yeah.
one way.
Oh, absolutely.
Nice switch.
The argument is that prior to SANS, you had storage directly attached to servers. And if I had a SQL server, I would say, okay, I need, this much capacity for my index of this type of RAID, of these types of disks, et cetera, et cetera. And then SANS came along and said, well, we can be a whole bunch more dynamic, because when we have direct attach, we're not that efficient. If I need to change something, I probably have to bring that server down. I have to have extra capacity in every server. So let me just have the shared pool here. And I would argue this made a lot of sense. It still does make a lot of sense in a lot of use cases. But spinning disks might only be able to do about 100 IOs transactions per second. SSDs are an order of magnitude 2, 3 more than that. So if you think about what a commodity SSD can do, it might be 50, it might be 100, maybe even more than 150,000 IOPS for every SSD. Well, we were talking about these controllers down below here. They've absolutely become the bottleneck. If you look at any all-flash array out there, any hybrid array, mixture of flash and disk, generally after the first flash drive, you're not getting any more performance. You're putting this flash technology behind a bottleneck, because again, these controllers are doing a lot more than your server up reads and writes. They're doing dedupe, they're doing compression, they're doing the file system maintenance, all the other things we were talking about. And this is a proprietary footprint. I mean, everyone in this room that's dealt with SANs and buying SANs and administering SANs, you're kind of used to the fact. You're kind of resigned to paying some astronomical amount of money for these components, that if you go on Amazon and look up and search for a read-intensive flash drive, you might be able to get them for a couple $100, $500 a terabyte, something like that, maybe $700 a terabyte at the high end. In an enterprise flash array, you're generally going to pay $5,000, $7,000 a terabyte. Again, it's the same technology. You can call up the same vendor that sells servers and sells storage, and if you ask for a flash drive in your enterprise server, it's probably going to be about 1/5 to 1/10 the cost. Why? These are commodity. Dell knows they're competing against HP, knows they're competing against Cisco, and you're going to play them off one another. That's a good thing, that these are commodity, and you can change vendors. And great things about SANs, you can stack up Dell servers next to HP servers, next to Cisco servers, and they don't care. And the reason they don't care is they're generally not communicating. They're communicating with the SAN down below. So you've got this nice reliable layer down here that you can carve up and allocate different chunks to different people, but it's very expensive. And maybe it's introducing sort of a performance bottleneck, because you can scale out n numbers of servers up here, 10, 20 servers, with these big massive Intel CPUs doing lots of processing in the server, generating a lot of I/O down below, and this is back of the room, a pizza pie. Every time you add another server, you're slicing up that pizza pie into smaller and smaller chunks. So, another thing. Again, because these things are so expensive, application owners, the infrastructure owners, have got to go and say, where am I going to be? Where's my company going to be in 3, 4, 5 years? generally these things are gonna be around for that period at least. Oh, go ahead.
Yeah, now you keep saying they're expensive, expensive, expensive.
Yeah.
Some of us that have been around for a whole bunch of years say, hey, these things are an order of magnitude less expensive and much more powerful than they were
Oh,
even
right.
10 years ago. So I don't like when you're saying they're very expensive, because I'm looking at it, what I used to pay for them and what I'm paying now, and I'm saying I'm getting a heck of a bang for the buck.
Yeah.
So
Okay.
I don't think you should be saying that.
Okay, here, do you?
Everything's perspective.
Let me
Take it back.
Correct.
No. Let me challenge you.
Okay.
We're not gonna throw any vendor under the bus.
Okay.
Does the vendor you prefer sell servers and SANs?
No.
They
That's
don't.
it. That's it? Oh, well,
Do they sell servers as well as storage technology?
my preferred is Nimble, and they didn't, but now
They
that
do,
they're part of
they do,
HP,
okay.
they do.
If you, I used to work for Nimble.
I used
If
to
you
work
ask
for
Nimble for 4 more terabytes of flash, and if you ask HP for 4 terabytes of the flash in the server, where's it gonna come out cheaper? You're saying, I need 2 terabyte flash drives to put into a server versus 4 terabytes of
Right, but if I
additional
put it
cache.
in a SAN, I can split it up among
oh, I love
multiple
that.
ESXi servers running multiple,
just the
multiple
cost.
virtual machines or servers, so.
Just the costs. Where's it gonna be cheaper? Up here or down here?
Are we doing cost per server or cost per?
Cost,
yeah.
Money out of your
Typically, the
pocket.
margins on
Integrated
servers
into
are
the
5
server.
to
One-
8%, storage is 60% industry-wide. That's what he's
You
referring
don't
to.
need the power
60%
supply,
margins on storage.
you don't need the fan, you don't need any of that stuff, plus the fact that it's the same as ordering RAM in a computer. What's cheaper, ordering the RAM when you buy the computer, or ordering the RAM after you've got the computer and you need to add to it?
That's a good analogy.
Yeah.
Yeah. Again, that's only my argument. We can agree to disagree on this point, but you're not gonna get me off that point.
That's cool, that's cool.
But you're right, I started selling storage in '86, and I used to sell 276 megabyte, 5 1/4 inch full high disk drives to a company called Digital Equipment Corporation.
Yeah,
$3,000 a drive.
correct.
Back in 1986, and they were buying $2,000 a month from me.
Wow.
Think about that.
Yeah.
And then we went to 200 meg, 3.5 inch drives, and we went to 760 meg, and then we finally got to the gig. So we've all seen it. I tell my kids there's more power on this thing than a multi-million-dollar Apollo workstation that I used to sell back in 1989. I almost said 1889.
Well, I bought a computer, a 386 in 1992, 2,500 hours, had 240 megabyte hard drives, 2,500 hours. I've got now, and this is a 5-year-old machine, an i5 dual core, 8 gig of RAM,
Think about it.
500 megabyte dedicated video RAM.
Hold it for a while. Keep going, John. I prefer
Yeah, oh,
The bottom line is that what budget you have per year and what you can get per year. And
Yeah.
next year, if you have exactly the same amount of money that you can budget, the following year, if with new technology, you can get more storage, more capacity.
yeah. And again, I think if you, even if you look at something like networking, you're absolutely getting more bang for the buck than you used to, but networking's getting a lot more commoditized. My only point is that traditional SAN infrastructure still tends to have a bit of a lock on. Again, you can look at folks who are publicly traded. Storage companies have huge gross margins. There's a reason for that. Server vendors have razor-thin margins. Even networking companies are coming down. And that's the delta between their costs and what they're charging customers. So there's something hyper-converged, which it's kind of what's old is new again. Again, folks see that again and again and again. By the time I'm done with this talk, SANs are probably going to be all the hot new rage. Sorry. But really, it's the idea of saying, well, let's not have this SAN. Let's not think about where we're going to be in 3, 4, 5 years. Frankly, let's compete with the public cloud as far as having more granular scaling options. That's how I kind of see it. So let's forget about the SAN as far as management. Let's integrate tools in here to work at perhaps the virtual machine level. That I think is a good thing. You know, the ability to start out small. You know, this is a 3-node cluster here, and as you need more, you can add another node whenever you want, to some n number of scaling capability. And every time you add more, just like in the SAN architecture, you get more CPU, you get more memory, you get more persistent store, as well as maybe more I/O processing. So every time you add a node, you get some more performance, you get more capacity, and that's good. Who wouldn't like that? But the biggest trade-off in my mind is that you've traded a nice stateless server for a stateful server. And what I mean by that is in the SAN, especially in a virtualized use case, you can lose the server. The whole entire server can go down. And virtual machines can fail over via high availability or fault tolerant. It's, you know, every hypervisor has the way of failing over virtual machines from server to server if something goes wrong with the physical hardware. And in the SAN, you had that persistent store down below. That was one of the really nice things about having that reliable layer down below with, you know, redundant controllers, power supplies, you know, disk layout, etc. In this case, folks are generally doing a mirror or a double mirror of the data, or doing some kind of a mirror with erasure coding, which is essentially mirroring the data, then doing some kind of spreading out the data across all the rest of your other nodes. But generally what that means is you're going to have 2, but to get the best protection, 3. And if you dig into the math at all, if this is at all an application that needs to be running, rather than being recovered from time to time, 3 copies is the way to go. And that has the obvious negative of okay, cutting in a third, your effective usable capacity. You're buying a bunch of infrastructure that, again, you can't use. So, okay, that's a bit of a drawback. But there's also the characteristic, because you're mirroring, you know, all your data is going to be at 2-3 locations. If a VM goes noisy here, becomes very active, it absolutely can amplify the workload on other servers. If it's writes, that makes sense. If I'm doing a write here, it's absolutely going to write in 2 other locations. But even reads, depending on the technology, not Nutanix.
I was going to say.
Not Nutanix, but depending on the technology, a VM may be running here, but its data may be elsewhere. So reads are going to traverse the network as well. So now we're having this thing we call east-west traffic. So again, we have to look at that, and absolutely a real problem as far as a problem.
Question.
Is in this type of environment, would you still have a dedicated network for storage, like to handle this type of traffic?
Oh yeah.
Yeah. No.
Yeah. Well, again, it depends on the vendor. It depends on the vendor.
Well, wouldn't storage be in each one of those boxes?
It is.
Right.
But for the communication,
And you're sharing
really the communication between them.
Right, and you're sharing the disk between them, so that
Yeah.
one goes down, the other one goes.
Yeah.
See, I would argue this is faster, because you've got a lot of some of the storage, and it tries to optimize to be local, so the storage for the VM is on
I
that
agree with you
box.
1000%.
And the
That's the
rest
correct
of it
statement.
in the background traverses at a 10 gig speed, certainly no slower than you did to the SAN,
Bingo.
but most of the time you're getting it off your box, which has a backbone that's faster than the 10 gig.
Precisely correct.
So, I mean, with a vendor, and I gotta say Nutanix, I mean, that's worked to optimize and think through, they've really worked at placing everything together to minimize the amount of times it's gonna traverse to get stuff.
And that's why
But every
convergence is
right.
around 45% a year, and SAN is growing -8% a year. Plotted out 5
I mean,
years.
So-
am I correct in that?
Well, you are. You
Yes.
are. So you hit on a really good point. And that's what we were talking about the SAN, about traversing a network to get those flash drives behind controllers. Every time you add another node, you're getting access to that local flash. That's a really good thing, as long as that's there. But now we're getting into, okay, if I'm running all desktops, for instance, it's a very homogeneous workload, by and large. Again, we can argue about, you know, boot storms and, you know, virus scans and things like that, but by and large homogeneous. If you need to add another n numbers of desktops, it's very predictable. I'm just going to add another y number of nodes. All of a sudden, if I'm running mixed workloads, you know, okay, I'm running SQL. They prefer much higher CPU, lower core counts for licensing. You know, so we're getting into different characteristics of different workloads. all of a sudden you might go, I might want one cluster for VDI, might want another for SQL, I might want a whole other cluster for different use cases. All of a sudden, I might be administering several other environments. And there's sort of this relationship of CPU, when you're architecting, there's this relationship between CPU and memory, flash and capacity per node, and that's fixed. Because of this mirroring and erasure coding, which is essentially just sort of a spreading the data out across nodes rather than a strict copy, when you add another node, it really has to be the same building block. It can be different. Like Intel just came out with new CPUs. You can roll out a new node with new CPUs, but essentially you're handicapping the rest of the nodes. They're sort of going down to the least common denominator of a given cluster. And the other sort of insidious part is you've traded, I might get pushed back, it's okay. You've traded one, call it vendor lock-in for another. Once you've gone Nutanix, or SimpliVity, or vSAN, whatever it is, generally because of a bunch of reasons, but inertia, you're not going to be able to play vendors off one another. You're locked into their hardware. You've got this great deal in this 3-node cluster. Guess what? The next 2 nodes are going to cost 5 times as much. It's just sort of the way sales guys work. Well, they got you.
Yeah.
You know.
Yeah.
So again, I'm not saying that this is universal. I'm not saying that this is everything about everybody. But when we're kind of looking at, ignore this last column for a second. In a SAN, you've got the virtual machine running on the servers, and you're traversing some kind of network to get to the I/O processing and the persistent store. That makes sense. The SAN is in charge of that work. HyperConverged, we put all 3 of those in one bin, and you're traversing the network to sort of talk to one another and do the mirroring and erasure coding across them. What Open Convergence is neither. What it is the virtual machine absolutely still running on a server, but I/O processing has been put up into that server layer to traverse a network to go down to the persistent store. Before we kind of talk about it, I'm just saying that's what it is from a logical perspective. So this is the one marketing slide. This is it. So Datrium, founded by the folks who founded, some of the folks who founded Data Domain, and then 2 of the principal engineers of VMware. Really, the story goes that they tried to look at on the back of an envelope, just like virtualization, just like deduplication, what can we justify in the back of an envelope to say, yes, okay, this is some new infrastructure that's going to solve some real problems in some interesting ways. So again, the whole kind of that little abstract that we put together, what are the nice things about SANs? What are the nice things about HyperConverged? Maybe what are the nice things about software-defined, the real leveraging as much commodity hardware as possible. Well, this is it from sort of a logical standpoint. I was going to do a little chalkboard, but I don't think there's any chalk in the room. We're just going to make it tough.
I think they lock it up.
Yeah, the valuable chalk. But yeah, I was going to use it, so there you go. So kind of starting out at the top. And we've got these 3 nodes again. Could be a whole bunch of them. They're commodity servers. They can come from anywhere. They can be existing servers. They can be new servers. They can be from Dell. They can be from HP, from wherever. We don't care. That's something we really like about SAN architectures is this commodity layer and the ability to play vendors off of one another. That's net a good thing. There's a little piece of software that runs on each one of the hosts. A Datrium a process that gets installed via our GUI. But it essentially creates a virtual storage controller. Okay. Not unlike the hyper-converged players out there. A little bit different than most. It does not run as a virtual machine. It runs as a process. It runs as a process in user mode. So it's not a kernel process, it's a user process. And inside the server, it creates an NFS mount point. This is not NFS. This is NFS. So it's a little stub. It's a little point within the server that appears and is a file system target. So it's just a kind of a network share within the server itself. So the other key component, and this is absolutely key, something we love about HyperConverged, is there's local flash in the server. Now again, is it better to buy cheap flash or expensive flash? This is a trick question. I don't have the answer. I think the answer is cheap flash. So we don't sell the flash. We think folks should be able to buy whatever inexpensive flash is supported by their hypervisor. So again, server supported by the hypervisor, flash supported by the hypervisor, from the most affordable source that they can get. What our software does is we can take ownership of some or all of it. We can select which we take ownership of. But now as part of that NFS file system, all data is read and written to that flash. It's read and written to it in a deduplicated and compressed format. So that, like, again, let's just do the math. Because a big part of this architecture is all about the economics of the solution. It absolutely is. You can solve these same problems if you've got an endless budget. Absolutely. But if you don't have an endless budget, the fact that you can get this for, because of easy math, $600 a terabyte. If we get 4 times compression and deduplication, which is about average, that means that folks' effective cost per flash might be $150 a terabyte. By far cheaper than they could get from the best source ever. Again, forgetting about dedupe and compression, just sort of saying, if I have flash in my laptop, I probably can't get it for this price. The reason that's so key is we don't want just a little bit of data living in that local flash. We want 100% of the data that's running on that server. So if I've got 20 VMs running on the server, we want 100% of those 20 virtual machines living in local flash. The argument goes, because then that's going to represent 50, 100, 150,000 IOPS in every one of these servers. And that's actually what happens, which is pretty cool. Now you could do that today. You don't minus the compression and dedupe, you don't need the Datrium software to do that at all. You could install a local flash. And again, that whole argument, what's old is new again. The other thing this software does, it says, well, we didn't want to have the host-to-host communication because that would reduce our flash efficiency, and it could introduce, depending on the workloads, noisy neighbor issues, contention between the servers and workloads. That can happen. So instead, each one of these mirror data down into our, we call it data node down below. Now these appliances, that's the only piece of hardware you actually have to, in this Datrium solution, Open Converged, you have to get from the vendor. You do. Okay. It is a commodity component, but it looks a lot like a SAN. Oh, go ahead.
Is there a specific advantage on using the user mode versus kernel mode?
Yes.
And using NFS versus another protocol, file system protocol that is more efficient than NFS?
Sure. So, 2 things. User mode, absolutely. Versus running it as a virtual machine, we're lower in the stack. The argument goes that we can be a lot more efficient and consume fewer resources by running as a process versus being actually, running in a virtual machine, in a virtual operating system. We can run at the hypervisor layer. The second part of that is user versus kernel is all about not wanting to bring down the server. Software is software. Engineers are engineers. The mistakes are going to happen at some point in the past or in the future. If there's a problem with this code, we don't want to bring down that server for a variety of reasons. If it's running in kernel mode, we crash, the whole server crashes. In user mode, we crash, we only affect ourselves. We don't affect the kernel, we don't affect the hypervisor, we don't affect, in fact, the server's access to other storage targets. It's also much easier to debug. That's the other thing, is the server's still running, to capture the error dump is a whole bunch easier to debug and create more reliable code.
Is built into this model the ability to fail over and load share and everything else that I'm used to on HyperConverged.
Yep. Yeah, and we'll jump into that as far as how it happens.
Thank you.
But yeah, good question.
The other thing that's kind of interesting, I mean, Will, because we presented this 100 times. The interesting thing in the platform is that we have encryption at birth, encryption in transit, encryption at rest, there's encryption all the time with the environment. So in this new world we live in, where security issues and hacking and loss of data, that's a huge benefit to the healthcare community, the financial community. The defense industry loves the fact that we have encryption embedded in the system, but the key takeaway is we're the only one in the industry that has it, where there's no degradation to your data reduction elements. I mean, one of the things that give you economics are a couple of elements. One is data compression, the other one is deduplication. Those run concurrently with our encryption with zero degradation. So in effect, it provides anywhere from a 2 to 3x economic benefit in the cost per terabyte. Not an infomercial, just a fact.
All right, so we got the, oh, I'm sorry, NFS versus Fibre Channel. So really, we're not traversing the network. This is not NFS down below. NFS is only within the server here. So it's only being presented within the hypervisor. As far as I know, there is no performance difference within the server itself of accessing NFS versus Fibre Channel. You could argue, okay, maybe the Fibre Channel protocol is a bit more streamlined than NFS, but we're not traversing a network. We're not traversing a physical NIC. We're not going over controllers in the back end. We're not worried about multipathing, something that Fibre Channel is much better than NFS at. So the only reason we picked NFS is because it's a file target rather than a block target. And we'll look at that when it comes to data management. If we're talking about virtual machines, if we're talking about containers, we're talking about files. Once we get into data management, backup, recovery, disaster recovery, essentially what are we recovering? We're recovering files. So unless we know we're going to recover every single file, every single virtual machine in the same exact way, in the same exact, for the entire server, which we generally don't, we're going to be concerned about what files we're going to recover in what ways. And that's why we chose NFS. We could be VM aware, we could be file aware.
Not clear. Do you have your own hypervisor? Do you use VMware or Hyper?
Good point. Yeah. So we are hypervisor dependent. We are operating system dependent. So the first hypervisor we supported, and you probably saw some clues of that as far as referencing ESX and things like that, was VMware. Recently released support for Red Hat KVM over, which is sort of the open source community branch, as well as Docker containers. That story is not done as far as the operating systems and hypervisors we will support down the road, but those are the big, I guess, 4 that we support today. And that's one of the 2 catches. I'm going to bring up 2 catches. That's one of the catches. Because if you were to say, look, I'm running physical SQL servers on Windows, I'd say we don't support that yet. If you're saying, hey, we're running Hyper-V, I would say, come back later. So that's sort of the catch number 1, is this is software running in the server, so it's got to support whatever the hypervisor OS is.
Whatever. You need the 85 and you'll take the other 15%
Exactly.
when you get to it.
So we know that we're writing locally, and we know that we don't want to mirror. So what we end up doing is mirroring the data down below here. And I'll highlight exactly how we do that in a second. But really, if you think about it, I've got all my data up here per the design. Doesn't have to be. This is not a hard requirement. But per the best practice, we have all the data living locally. What that means is all the reads, when things are operating correctly, 99% of the time, reads will never traverse the network. So looking at folks' I/O patterns, maybe 70% on average of IOs are reads. Right off the bat, we eliminated 70% of the I/O traffic to the storage layer down below. Other thing, these really are storage controllers. So when we're looking at other environments that might have, SANs, not hyperconverged, don't yell at me yet. I know, but we really can have 128 active storage controllers. It's really not a fair fight against, your traditional SAN architectures that, again, might have 2, in extreme cases, 4 or 8 active controllers. Well, these are controllers you're not even really paying for from a hardware perspective. They're freeloading off of existing infrastructure that might already be there. And they really are doing things like RAID. It's not happening down here like a traditional SAN. We were talking about that before. Dedupe, compression, encryption's happening up here. Replication's happening up here. Disk rebuilds, they're farmed out here. File system maintenance, the space reclamation and garbage collection, it's all happening up in this layer. Things that can bog down your traditional SAN array are not happening down here. What that means is, these are a nice, reliable platform. We OEM them, we don't make the hardware, we make the software. But these can be very inexpensive, especially, even when compared to a Nimble. And in our case, it's not that we're nice guys. It's not that we, or that we've got, some magic, formula to getting more bang from an Intel CPU. It's that we're farming that out up in this layer. So, with that as a backdrop, how does it work? This is not normally something I dive into unless really asked about, but I know that this is a technical crowd, so I thought I'd dive into it, right? Just any objections with getting a little bit more technical?
No.
All right, good. All right, so we've got the host up here, we've got the data node, or we used to call it a net shelf down below. Now, something that occasionally comes up as a question is, well, okay, you're mirroring down to the net shelf. I get how reads can be really fast, but our writes can be really slow. Well, what ends up happening is a write comes in, immediately written to a small local RAM cache. I'll also get to the second cache in a little bit. Second thing that happens is it traverses the network, sent down to an active controller's NVRAM, and mirrored to the other controller. We always want on both controllers, at least on one data node, at both controllers, and then the acknowledgement comes back. Only at this point are we going to say that write is acknowledged. Because if there is a failure in the host, or if there is a failure down the net shelf, we want that in several places just before we acknowledge that it's been done. But it has not been written to any SSDs or disks down below. It actually has not been written to the local SSD layer in the server itself yet. And that's for a key reason. Because you don't want to do a bunch of small, even though it's an SSD, you don't want to do a whole bunch of small IOs to it, and you certainly don't want to do a whole bunch of small IOs down to the disk or SSD layer down below. We're just not going to get the performance that we hope to. So, and this is a misconception I had until I started working here, is that, well, the reason the SSDs in my CN are so expensive is because, well, we got to lock them down. We have to know exactly what they are to write to them and read from them in exactly the right way. Well, it turns out it makes sense. There's an API. The SSDs tell the interface working with it what its data layout is, what its preferred page size are, etc. So these actually are optimized per the SSD that the end user, that the customer SSDs are put in there. So what ends up happening is we start doing a bunch of writes. Could be very fast. It could be over time. But eventually, that little RAM buffer for that particular data stream is going to fill up. We're going to fingerprint it, dedupe it locally. So again, this is not deduped across other servers yet. Then we're going to flush it down to the SSD. Then we're going to indicate to the SAN array that it's been flushed to the local SSD, and we're going to push it down, not in a small operation, not in that little 4 or 8 or 64K operation that it might have been, but we're going to flush it down to these large multi-megabyte. Might be familiar with Nimble. A full RAID strike rate, with a RAID 6 essentially down into the disk or SSD layer down below. So now it's fully protected. It's living in local SSD. and it's living down here.
Now, when you say flush the SSD, do you still have the data in RAM until other data has to replace what's in RAM? Like Nimble, so that if someone adds
Oh.
the same data that's in RAM, it'll take it out of RAM before
Oh.
SSD?
Okay,
Is that
yes.
what happened?
Yeah, so, but it's a little different than, but Nimble, but yes. Yes, so we'll see that in a second.
Can I ask you a question?
Yes.
What happen if you haven't flushed flushed the in the sand and there is how you keep the consistency if there is a problem between the time you did the write on the host and the
Yeah,
sand?
so really technically, as far as this point is concerned, you know, we're at this phase where we wrote a, I'm sorry, here. As far as this phase, we've written one IO, whatever it is, whatever block size it is, it's in local RAM. Obviously, that's not good enough to acknowledge it. Write it down to one controller, mirror it to the other controller, acknowledge back. At this point, it is consistent. You know, again, we can start talking about other IOs coming into the mix, but they are consistent at that point. We can lose the host, we can lose the entire power to the data center. Obviously, you're not going to have this anymore. You're not going to have a host side data in the RAM, but you will have that NVRAM in both controllers. Now, if there's some sort of a corruption or some sort of an issue with one controller, that's where we really want the other controller to come in. That's why we need acknowledgements in both locations. Now, to continue that story, flush it down to SSD. It also gets indicated to flush it down to the SSD or disk layer down below. Now you could argue, well, what happens if the power failure or issue happens right here? Well, same thing. This is just a cache. You can lose every cache layer. You can lose every server in the mix, just like a SAN. They're stateless servers. Same thing. I've got my consistency right here. Now the consistency is not on a disk or SSD yet, so you can have some data in sort of this mixed mode of I've got some in SSD, but you never need anything in this server. It's a completely stateless design, meaning I can lose all my servers. Now that's not good. I'll lose access to my data, but your data is still consistent. Does that kind of make sense?
Yeah.
Okay. Maybe we can go into it more and.
No, I'm thinking also that from the database point of view that you can keep that as an atomic operation when you do the. I mean,
When you start getting
how
into-
you roll back when
Yeah.
if something happened right in the middle.
Yeah,
And I
so-
go back to the. I mean.
So when I asked what is the most difficult thing about the actual architects of the design of the product, what is the most difficult thing that they did to create this? It was creating I guess a scalable I/O architecture, where again you can have these tens or more of active controllers that are not communicating with one another. They're doing simultaneous IOs all around the place, reads and writes all around the place, down to a scale-out storage layer down below with next to no communication amongst them either. Now that does rely on something that's 10 layers over my head. How they actually do that, I don't know. If anyone's really interested, I know our founders are very, very open about getting into deep conversations with customers and anyone interested in technology, but I'm going to freely admit, I don't know how they do that, but they do say that is the groundbreaking thing with this technology is being able to have this scalable I/O processing, scalable storage, without the sort of that horizontal communication layer.
I'm seeing, now maybe this is just your diagram, I'm seeing 10 gigabit interface on VM in there. Is it really?
No, that's simplified. Yeah. I'm sorry.
Right,
Oh yeah. So you would typically have
at least 2?
4, if not 8, and it could be 10 or 25 gig, and you can have any number coming out of an ESX host like you normally
So
could.
is it, 10 gig base T, is it, what
Right.
interfaces are there?
So 10 gig could be RJ45, it could be SFP+, it could be LC Optic. It can be 25 gig, which is LC Optic or SFP+.
Can we get the 40 gig,
We're not 40 gig yet, so we're 10 and 25. So,
Okay,
yes.
Then you can do link aggregation, go hold on 10 in parallel. A lot of
Oh,
people
yeah.
Do that, be either saying screw you Cisco, use Cisco or something like that, charges too much for the big one.
So, interesting.
Verizon did that to them very publicly, saying, get your big pipe prices down, because we're gonna be buying a lot of them and doing link aggregation, which just works.
Yep.
And you know, like, it doesn't matter.
So interesting point. So because, and this is one of the things, we are, for lack of a better term, we are the pitcher and the catcher. We have a file system up here, we have a file system down here. One of the implications of that is what Mark talked about before. Doing the dedupe, doing the compression, doing the encryption means that we can have end-to-end encryption, but the other part of that is we can also control our own multipathing. So even though this is NFS up here, we don't rely on ether channel or traditional link aggregation. We are doing that ourselves. So every NIC. So if we had four 10 gig NICs, so 8, every one of them would have their own IP address, and we have a floater and things like that. But we take care of them. We take care of the multipathing ourselves. So now you actually can have one data stream on a 10 gig network that does more than 10 gig worth of throughput. That's something traditional NFS can't do. Fibre Channel iSCSI can, but traditional NFS cannot. We can, because we take care of our own multipathing. Again, that's just sort of one of the offshoots there. But okay, let's continue. So we've written it down below. Then we flush standard VRAM, get ready for a new set of writes. So what about reads? So again, things can be in different locations. We might be in RAM, we might have some in SSD, we might have some in the NVRAM down below, or maybe down in the net shelf. Typically, very rarely actually, it's going to come off of local RAM. Usually, 99.9% of the time, it's going to come off of local SSD. But if it doesn't, it's going to go down to the net shelf down below. So, to compare and contrast, this is our cache. And I guess this is our super cache, the local RAM in the server, but this is our cache. Generally, because we size it, because of the economics, because of the dedupe compression, all data is going to be running out of local SSD. Now, there's a couple scenarios where it will hit the disk. One of them is if we, missize it. We don't have enough local SSD. Well, then you're going to have some hits down on the disk down below. And that's something we try to prevent. We highlight it very, very, front and center how much effective flash you need, and how much flash you have, when you're going to run out, that type of stuff. We highlight. But if you think about it, how much of a mistake is it if you don't have enough SSD? It's a call to HP. It's a call to Dell. It's a call to Cisco to say, hey, I need another 2 terabyte drive, another terabyte drive. I want to integrate it in there. The software, go ahead.
The SSDs still have very, I think, small, finite life. You think about which particular type you get. They're all small. You write to them enough, they commit suicide.
They do. If you especially, well, it does vary.
Not with this kind of hardware, like.
Well, if you do the wrong thing. So the key thing is, if you do the wrong thing, especially random overwrites, small block random overwrites, you can blow out any SSD in a very, very short amount of time. The key with all the call it next generation flash technologies, I'll put Nimble in that bucket, I'll put Pure in that bucket, I'll put a bunch of the other guys in that bucket, but I will also put Datrium in that bucket. If you write to them in an efficient way, in this append file system, where you're always writing forward, even though you're doing random writes, you're aggregating them and you're flushing them down somewhere down in the future. Now you do have to do garbage collection. There are garbage collection operations that happen within the SSD, there's garbage collection operations that happen within the file system, but you can greatly minimize. Even if the application up above is doing random writes all around the place, you can greatly minimize that behavior, those overwrites on an SSD. So when customers ask us, what SSD should we get? Absolutely, read intensive, not write intensive, which have the higher endurance. We see customers should expect 5-year endurance from commodity read intensive flash drives based on this algorithm. Now again, that's not unique to Datrium. We heard Nimble. Nimble does something very similar. My previous employer does something very similar. Pure does something very similar. But you're not going to get that on just every file system, every data layer. And that goes back to the very beginning of there are these storage upheavals every 5 to 10 years. That is one of the characteristics. We have these new SSD drives. We can't run this on the legacy SAN that's been around for 20 years. It's not optimized. It's optimized for disk. It's optimized for inside or outside of the spindle. It's not optimized for aggregating IOs and aligning.
But if you did happen to have a data SSD, they're not great, and you just throw another one in, it's just like JFI or whatever.
Yep.
And you're off to the races again.
Yeah.
I think with a lot of flash array vendors that have out there predictive analytics, what they're doing is they have they continuously taking telemetry data every 30 seconds over the life cycle of that SSD. And then profiling behavior attributes, and they have such predictive data now they can know when you're flash. I was in flash company for 5 years of Pure, where we knew when it was going to rebelliate. We could almost say by next Thursday that drive is showing characteristics, and we probably want to swap it out. So we want to be preemptive in our support model. And that's the way all the flash vendors are getting away from, to your point. The big issue 5 years ago with flash was the fragility of flash, the weird characteristics of flash, and wearing out quickly. Even consumer grade flash has come tenfold in the last 4 or 5 years because it's now commodity. It seems like Toshiba and all the big vendors have such volume of this that it will be the complete demise of disk, except for the fat disk, which will be used for archive. Because of weird characteristics and the robustness of all flash is getting better to the point where it'll be as commoditized as a disk. It'll be the same cost per terabyte as a disk. If you think about that, it's not that far away.
So the next question is, okay, I get it. I get the advantage. You've got all the application data living local in the living on SSD in the host. I get it. My reads are going to be really fast because they're coming off of local SSD. Writes are going to be a little bit slower because they've got to be mirrored down to the data node layer down below, but it's still pretty darn fast. What happens when things like failures happen? What happens when things like vMotions happen? In the case of vMotion, again, just like always, the servers can be moved, the memory and applications can be moved from host to host. Now it's not going to live in the local flash anymore. We could always access down the net shelf down below. Those come in 2 flavors. They come in disk and they come in flash. But we don't want to access that. That's really there as a backup copy. We will access local flash host to host. That is one of the 2 times we will access, we will have that east-west traffic is during a vMotion. So we will access the local cache and actively flush back to the other server as fast as we can. So there will be a big push or a big flow of information from host 1 to host 2.
But once everything's flushed, then host 2 is the new.
Host 2 has it.
is the new master. And
Oh, yeah.
They own everything.
Absolutely. In the case of a failure, again, depending on how it's configured, again, defaulting back to VMware, whether it's HA or FT, the VM is going to fail over. Now, there isn't that local flash anymore. What ends up happening is the IO is going to go down to this, the data node layer down below, and now essentially this data node says, aha, this is the reason I exist. I'm starting to get reads. I shouldn't get reads. Well, part of the deal when we wrote the data down into the net shelf layer was organization. This is another reason, it's actually an NFS target up above. We want not only this layer, but also this layer to be file aware. So it actually organizes the best it can the same file in the same large RAID stripes. So if I start getting a couple IOs down below here, it's not just going to respond 4K operations. It will, but it's going to say, huh, I now want to throw the whole kitchen sink. I want to flush this entire file back up into this cache layer. So ingest speed of a disk-based node is about 8 gigabytes per second. We can go back at about 16. It's a tremendous, a flush of information back up the wire, because that's what we want. We don't want to get disk-based or even network SSD-based performance. We want local SSD performance at all costs. That's kind of the goal of that. So the net effect of this, again, I'm not saying this is the right architecture for everybody. I hope it is. I don't know, but the net effect of this is you can start out really small. I mean, technically, it wouldn't be HA, but you could have one node. Maybe it's just a little test dev environment or something like that, and be able to scale independently. You need more flash, just like HyperConverged, perfect. You need more capacity down below, perfect. And right now, we can go 1 to 10 nodes down below. That would be a pretty aggressive D-Newton compression ratio. But generally, we say scalable up to a petabyte of capacity down below and 128 compute nodes up above. But if you see this, up to 18 million, again, 4K random read IOPS. That's a tremendous amount of performance. And guess what? We haven't thrown a single high-performance, expensive component at the mix. That's kind of the magic of it. Now, what's the second catch? The first one is we've got to be compatible with the operating system hypervisor up above. The second is we're freeloading here. We are. We're consuming resources. So the first one is memory. We saw a little picture of that. It's actually very modest. They want to be very, very memory efficient. The base consumption is 5 gigs per server, plus 2.5 gigs per terabyte of flash. So if this server had 2 terabytes of flash in it, we would consume 10 gigs of memory. That's something we have to size in and say, okay, we're going to maybe reduce a little bit, but okay, a little fraction. CPU, we know that storage controllers can consume a whole bunch of performance. We consume up to 20% in one mode or up to 40%. We call the first mode fast. Why wouldn't we? We call the second one insane. That's just a kind of a fun nod. Oh, there we go. Yeah. Insane mode, everyone's had. That's what that's referring to. Is it's a selectable percentage. It's a soft reservation, but we will consume it of the amount of performance. So that's something else when we look at an existing workload. So what are the CPU requirements? Most folks, again, we see a lot of them. We run our analysis tools and things like that. Most folks are kind of teetering between 25 and 30% CPU load on their individual loads. Not everybody. What that means, though, is if a customer or a use case is around 20, 25, 30%, we will not impact their VM density. If they were much higher than that, we might. We might say, okay, well, maybe we want to upgrade, maybe we want to throw a new server into the mix. But that is part of the consideration.
So, whereas, in most cases, you might consider a dual CPU server. If we're going to go with your solution, would you say, hey, maybe you should consider a 4-processor server?
No, generally we don't impact. But you can. In fact, I think this is where, a little out of order, but you can. And that sort of is the nice thing about it is if you had some high performance database application, you would say, hey, not maybe for Datrium, but for the application, I really want these 2 servers to be quad socket and the rest of my farm to be dual socket. Absolutely, you can go ahead and do that.
Well,
Yeah, but if
would
you're-
you say, well, if I was considering a 12-core processor, now should I consider an 18 or 26-core processor?
And that's a key part of the analysis. I mean, if you're really going to, if as part of looking at a use case saying, hey, we're really going to consume some large percentage of a 12 core processor, and a 20% margin on top of that is just not going to work, then the simple answer is yes.
It's just
It's just going to be yes.
Larger core processors?
Yeah, we would get more. We want more cores.
Unless you're gonna put a desktop machine in as a server, you're gonna get a minimum 4, probably 8 cores anyway.
Well, nowadays, you're gonna get probably 10 or 12
Right.
as a minimum, and likely 14, 18. or whatever.
Exactly. So it could happen, but that's a key part of the analysis. Most folks, this is probably, one of the things that people get wrapped around the axle of, and rightly so. But when we actually do the analysis, we've got a tool to look at this, what their existing use is. Most folks are somewhere around 25 to 30%. I mean, that's the reality of it. And again, we can go into the tool, but yep.
So, in terms of architecture, and if you have a distributed environment where you have a corporate office with remote office all over the country, how would you size and how would you architect your system?
Yeah, so I mean, assuming that there's actual infrastructure in each location.
Right.
Yeah, so really, we've got 4 different configurations of an individual node down below here. They can range from 25 to 100 effective terabytes. And that might sound like a ton, but it won't in a second. And you would say, well, okay, what are we doing for hosts today? Well, if a smaller office only has 3 hosts or 2 hosts or 4 hosts, something like that, it would probably be the same number. In fact, if this is part of the consolidation of saying, well, okay, we're going to go from 6 to 3, generally we don't impact the server density, so generally the server count's about the same. Again, if they're upgrading, from 3 generations, to something modern today, we're going to be aligned with, probably your traditional SAN architecture. However many servers they're going to need, we're probably going to be in that same ballpark. From a storage perspective, this is where things get interesting, because you say, well, okay, now obviously, a core hub site is going to need a whole bunch more, and a smaller site somewhere else is going to need less. But if you think about it, this is your performance layer up here. The analogy, maybe every server is kind of like the performance of an all-flash array, literally around 50 to 100 to 150,000 IOPS. This is your low-cost capacity tier. This is essentially your backup layer. You would never stack up, even with very efficient redirect and write snapshots, you would never stack up 6 months, a year, multi-year retentions of snapshots on an expensive all-flash array. You wouldn't do it on a hyperconverged architecture, although you could. Technically you could. The reason you wouldn't is cost. The cost of capacity is so expensive, you would never do that. But now we've got this split architecture. All of a sudden, you don't have to, but you can. We're operating at the VM granularity, or the file granularity. All of a sudden, you can stack up weeks, months, maybe even years of retention. Of course, you're going to consume capacity, but the capacity itself is much more, equalogic-like than pure-like, just to pick on Mark.
Aside from the cost of the flash SSDs coming down, what about flash cache to spinning platter?
With respect to,
So,
The tiered architecture?
yeah. So you're
Yeah, I mean,
writing to your flash cache,
yeah,
which then, when it has the time, it just writes to the spinning platter to store it.
right.
And it's even fault tolerant because it's basically SSD. So even if something happens to the system and it takes it down, so it's stored in the SSD. So it gets
Right,
has time to write.
that's a good analogy. That's a very similar analogy. This is just on a larger scale. This is saying, well, yeah, that's within one drive. This is exactly that within a larger infrastructure that's sort of expandable in a couple different ways.
It's a so-called
Yeah.
hybrid drive.
Yeah, this is a hybrid infrastructure environment, just stacked up, sliced in a slightly different way. So I'm going to keep this within our time limit. Oh, go ahead.
So you have your boxes, your appliances, you said
Yep.
25 to 100 terabytes.
Yep.
So I'm 25, I fill it up, I put another one in. Will it appear like Ecologic now that I have 50,
Yes.
now I have 75? So it just kind of says, oh, boom,
Yep.
right? It just concatenates them together.
And kind of the elegant part of it is, if you think about an Ecologic or a Nimble, there had to be, I'm not saying any of this is easy, I'm not. I didn't write one line of code, so again, it's easy for me to be up here and say it's easy. But But if you think about it, the Equal Logic had all these independent nodes, Nimble has all the independent nodes that have to work out the scale-out architecture. That's pretty hard to do because you have all these independent storage controllers up above. In our architecture, in the Datrium architecture, you've got those virtual storage controllers living in the servers. Each array, call it, it's just a pool of disks. It's really just like adding an array to a traditional SAN, where now you rather than 12 drives, you've got 24, you've got 36. They just have more drives to deal with. That's literally what they do. And say, oh, now I have 36 drives to work with. Let me figure out my RAID architecture. Let me do my disk rebuilds. Let me do my file system maintenance. That's kind of the cool way that the scale-out is a little bit different. But
do you have customers that they have used this technology or this architecture for high performance computing or like a computer cluster or Hadoop?
Yeah, when I think of HPC, generally I think physical servers. We don't support physical Linux, physical Windows yet. I think we actually do have some virtualized Hadoop. I think we do. I can go back and look, but none of my customers.
Well, many of the customers, many of the high-performance clusters, they use Linux.
Right, physical Linux. So I would expect them to do that when we support physical Linux. We just don't support it yet. I mean, I think they should. So the net effect of this is, again, I'm going to go into a little bit. This isn't like a big brag thing, but shoot, this is the net effect of it.
It's not like it is.
Yeah, good point. But this is where I get so excited is we're not throwing millions of dollars of hardware at this problem, but literally they put up this IO mark. As far as I know, very legitimate folks, the independent group, 10x, 5x, and it was a 60-node cluster. It wasn't even a 128-node cluster that they threw at this problem. We were able to run 10 times more virtual machines, 5 times more virtual machines. Kind of cool stuff. And this is just in our lab. This is a full 128-host environment. And it's all reads, so again, take it with a grain of salt. But it's really doing 12 million read IOPS in one cluster. Now again, it's not a fair fight. We had 128 active controllers. And this is kind of the other side of it, is saying, well, it's a lot more than just a cached architecture. It's this end-to-end architecture where if you're doing the decompression in the storage controller up above, as well as the encryption, really is going to be end-to-end. So now, if the intrusion is here in the network, guess what? We're looking at encrypted data. Data at rest, encrypted. Over the wire to replicate, it's encrypted. Now again, of course, there was talk about firewalls. You still have to protect the front end of your environment. This doesn't mean we've solved security soup to nuts. But what it has done, and we're not the only end-to-end encryption software out there, but as far as I know, the only one that's not impacting deduplication and compression. Well, I can show you a really quick demo maybe. But again, we're doing the operations at the VM level, which I think is the file level. All of a sudden now, creating these protection groups. Biggest limitation, 2,000 snaps for a virtual machine. That's a lot. But if you're snapping every 10 minutes, you're eventually going to run out of that bucket. And then again, the ability next month to start pushing these snapshots into the public cloud. And start saying, oh, okay, back to the very beginning. Is on-premise the only way to go? Of course not. You've got another tool in your toolbox now. You've got public cloud. Where does it make most sense for this particular use case? In my mind, backup and retrieval. That's a great use case. That's where the cost justifications, not having a second data center, start making a lot of sense.
So these snaps are within your software?
Within our software.
As opposed to using a Veeam type of thing to put it someplace else?
You can use Veeam. You can use Combo.
Would you use both?
You could use both. But this is specifically only Datrium.
If you happen to be a greenfield opportunity where you're going to centralize on one architecture, one platform, theoretically you don't need those backup tools anymore if you backed up. the cloud backed up within our.
Right, but I don't wanna put my backups on the same, storage as my primary.
Correct.
That goes, then the backup goes.
Correct. Yeah. So this is the argument that I can push my Datrium snapshots in Datrium format up into AWS. So you would put in your AWS credentials with, in your AWS account, and we would push, rather than pushing our snapshots to another Datrium target, we push them up to the public cloud, up into
Yeah,
S3.
but again, that's still at a relatively slow speed. Can I push it to another high speed?
Oh yeah, you can push it.
At my own location.
Oh yeah, if you want to back up using traditional tools like a Veeam to another target all day long.
Yeah, so you're not bogging down the production servers.
Well,
Send it-
you just want an alternate means, so, because
Yeah.
everything.
Yeah, we want to
goes
be as
like,
open as the rest of the storage vendors.
Yeah. No, Veeam is a partner, Commvault's a partner, Rubrik, Cohesity, all partners.
It's just that you want multiple
Oh yeah.
means of backup or whatever.
Absolutely.
The other advantage of the architecture, why we're growing so quickly, is there's an awful lot of cost avoidance in our messaging. A lot of our customers are budget constrained, and if they can leverage their current CPU infrastructure, not have to buy any controllers, there's some advantage there. Or if they just bought some new controllers and they're underutilized, there's advantage there. People that are trying to consolidate with less vendors, some of them are looking to have, picture capture, maybe us as the back end as well. And the cost, we didn't get into the cost, I don't want to get into too much, but we're so dramatically lower cost than any other vendor out there. This architecture is designed to keep your tier 0, your tier 1, and your tier 2. You keep archiving if you have people living on-prem. So we have a very interesting feature function set here where we can sell a 10, 20 terabyte solution, and we can build that same solution into a petabyte solution. We can do 50K IOPS with the solution. We can build it to a $500,000 or $1 million by simply adding blades, CPUs. The thing that brought myself here, and John independently of me, when we met with the founders, they said there's no need for people to buy disk arrays in the future. What are you talking about? We've been selling disk arrays for 19 years, you're nuts. And when we were done hearing the rationale and the thought process behind it, in the economics, I was in the middle of one of the biggest insurance acquisitions of a $5 million array deal with Pure when we came to the realization we couldn't do it even for $10 million, but the architecture here could in effect do it for $650,000. So the economics, someone's talking about price collapse and just how dramatic it is. With the utilization of all commodity in a software-defined model, there'll be no reason for the fancy, expensive infrastructure. The underpinnings will no longer be needed because we'll be able to give resiliency, we can give encryption, we can give ease of use. We didn't even talk about today the fact that when you put a Datrium system in your environment, there's no more need for a storage administrator. We've automated and eliminated the majority of the storage tasks. Because someone said it earlier, one of the most important things people need in this new IT world is simplicity everywhere. And the intent is this is almost a self-contained user environment.
All right, so I think we're just about out of time. Oh, go ahead.
Yeah, what's the minimum storage that one can buy, and what are your target flash?
Have a shelf.
So we have two different flavors. Post deduping compression, the all flash is a 50 terabyte tray. It's really 15 usable. The disk is 30 usable, about 100 effective after deduping compression. We have a half capacity of each one of those, so call it 25 effective, 50 effective flash and disk.
And as long as you keep talking about how you're lowering the price, if that's your entry level,
Yep.
what are the retail prices of those platforms?
I was listening, we were talking about
Retail price.
mechanics all day long.
Well, no, I'm not asking half the price of the mechanics. Give me a number, what are the price
The list
numbers?
price on the one we've been selling the most of for the last 6 months, the list price is $96,000.
That's 100 terabyte.
Yeah, it's a 100 terabyte box, and
Is
the
that
average sell
SSD
price to a
or
customer is $49,000.
That's the spinning disk.
That's a spinning disk.
So really the argument around disk and SSD is generally, there's no performance difference, because all of it's happening up in the local servers. There's only the case where write ingest, the write ingest performance of the all-flash is about double the performance of disk. So if you had a very write-intensive workload, you might prefer the SSD for that use case. If you're running Oracle RAC, sort of a multi-writer type application, that's a use case where you might consider SSD. Or if you just had sort of the more blanket rule of we don't want any more hard drives in our data center. There are some folks like that, cost be darned, we're going to have all flash. Okay. But other than that, or there's a case of an actual failure where IOs are now coming off of the disk layer. Until that cache is repopulated, which is going to happen pretty darn fast, but until that happens, it will be happening at degraded performance, degraded latency. So,
yeah, one of the challenges with all of the all-flash array vendors that we're competing with is that when you want to increase capacity to a certain level, you have to do a hard transplant. You got to go to the next generation controllers. They're cost prohibitive. Or if you don't need higher capacity, but you need higher performance, you got to do the controller upgrade. It's cost prohibitive.
all right, with that, I think, I know we're butting up against the time. We should do the drawing and let anyone ask any final
Just a
questions.
very quick question.
Yeah.
I don't know if it makes sense, but does the software, are you able to work with using your GPU for the encryption and decryption?
Oh, yeah. Okay.
For, if
For
you
the
have a
encryption.
CPU, a machine with the GPU with several thousand cores,
For
encryption, decryption, or some other stuff? I mean, I don't know if
so for use of our encryption or use of
your encryption.
So we actually leverage I'm gonna get the acronym wrong. It's AESNI, something like that. Intel actually has a library that we can leverage within the CPU to get our FIPS 140.
But not the GPU. So
Not
if you
the
have a
GPU.
machine with the GPU, so it's in the CPU with the
We
board.
get it off the CPU.
There's another one over here.
There is a FIPS 140 certified algorithm that has to be done in software. Then actually there is a performance set if we leverage that, and we can select from one or the other. It's dependent whether the customer needs FIPS 140 compliant or certified. We can do both. One has performance impact, the other doesn't. So anyway, but again, I want to thank you all. I love the back and forth.
Great questions, folks.
Again, you'll have our contact again. I did get to the demo, but I love the back and forth, and it was a great use of my time. Hopefully
Thank you
it's
so
a
much.
good use of
It's
yours.
very-